one.
I'm Yet Fees.
25 years from now is a really long time into the future.
In my field, we are headed for some challenging times.
And some of the subject materials we work on are some of the wickedest problems that humanity is facing now.
We need to change the way we build houses. We need to change the way we structure cities.
We are experiencing a great revolution in technologies.
Understanding how organisms adapt to climate change.
To find more spaces for Indigenous languages to be spoken.
You're familiar with the Star Trek idea where Bones puts the tricorder on the patient's neck and then has everything about that patient and can prescribe a customized intervention. Well, essentially, that's where we are going.
AI will play a much more important role in education.
I see a more hopeful direction.
Digital medicine will then become the great equalizer.
We've only seen about this much of the universe, and that's what we want to change.
Pretty sure we will do several takes on this.
Take 517.
Take 2. I have to restart it.
There might be one word that I want to get in there.
My last line was not good though.
Bingo.
Yeah, that was great.
That was good, yeah.
And of course, I believe that every laboratory 25 years from now will have a small dog.
Good evening. I am Deborah Tatone, Associate Vice Principal Research at McGill University. It is my great pleasure to celebrate with you an exciting signature project of McGill University's 200th anniversary, the Bicentennial Digital Time Capsule Project. The Bicentennial represents a momentous occasion for our community. It is an opportunity to reflect on McGill's first 2 centuries and to envision all that the university will become in the next 100 years. In the spirit of forward thinking, the Digital Time Capsule Project was launched to bring together over 50 of McGill's top researchers to answer the question, what will be the biggest change in your field over the next 25 years? Their responses are featured in this one-of-a-kind legacy collection of short videos, which you can access on the Bicentennial website. As the Time Capsule Project drew near completion, what no one could have predicted was that a pandemic would change our world as we knew it. For this evening's event, we have brought together a panel featuring 3 McGill researchers who participated in the project and who are Royal Society of Canada Fellows and members of the College of New Scholars, Artists, and Scientists. Once again, we're asking them to look to the future, but this time to envisage the future of research in a post-COVID world. I will serve as the moderator for the panel. It's my pleasure to welcome our 3 panelists who each represent different disciplines at McGill, but share a deep commitment to research excellence. Rowan Barrett is the Canada Research Chair of Biodiversity Science at McGill and a professor in the Department of Biology and the Redpath Museum. Suzanne Lajoie is a Canada Research Chair in Advanced Technologies for Learning in Authentic Settings, a member of the Institute for Health Sciences Education at McGill, and a professor in the Department of Educational and Counseling Psychology. Natika Pai is an associate professor of medicine in the Division of Clinical Epidemiology and a principal investigator at the Research Institute of the McGill University Health Center. The 3 of you recorded your time capsule videos in the fall and winter months just prior to the outbreak of the pandemic. The world has drastically changed since you made your predictions about the future of your field in the next 25 years. I would like to start by watching each of your time capsule videos and then reflecting on how the pandemic has reshaped your research. We will then move into a conversation about the future of your research in a post-COVID world. Let's start with Professor Lajoie's time capsule video.
Hi, I'm Suzanne Lajoie. I'm a professor in the Department of Educational and Counseling Psychology, and I'm also a Canadian Research Chair in Advanced Technologies for Authentic Learning Settings. Where I see the field going in the next 25 years is that AI will play a much more important role in education, all from kindergarten all the way through university. And I think that technology will really be created as computers that care for us, that we will create personalized learning environments based on individuals' cognitive skills as well as their emotional needs, and help them along learning trajectories that help them learn at their own pace. I do believe that we'll learn to work in groups better. Technology will help us monitor our emotions while we're learning in groups and help us regulate those emotions so that we see that when obstacles are occurring, say in a team problem-solving situation, we'll be able to notice those emotions and modify them. Emotions play a huge role in education. The more positive emotions we experience, the more we'll approach a learning setting. The more negative experiences emotionally, like boredom and anger, will take us away from learning experiences. So technology through multimodal sensors will be able to help us identify when students need to reappraise their emotional situations and move forward. The other thing I think that will happen is that we'll have virtual immersive environments for students where they will get to have virtual apprenticeships where they will learn to be pick their own careers at any particular point in time, and they'll be able to try on what it's like to be a scientist, what it's like to be a physician. And in these virtual environments, they'll actually be able to interact in a way that a scientist or a doctor would to see whether this is something that would be fun for them and something that would be challenging. So bricks and mortars environments where everybody's sitting in a class with 30 people looking straight ahead may change. I think that globally students will meet with other cultures. Language won't be a problem because technology will automatically translate languages for people so we can hear and give information and understand people more globally. And I think this will be huge because we'll be able to share multiple perspectives from other countries and learn other cultures and what people do in other places. We'll learn from each other. And that's how I think technology can support education in the future.
Okay. All right, Professor Lajoie, your research lies at the intersection of education and technology. In your video, you stated that AI will play a much more important role in education, leading to tools like personalized learning environments and virtual immersive environments. Since you made this prediction, the pandemic has moved us even further into using online environments for work and personal communication. How has this shifted your research?
Thank you, Deborah. On the positive side, the absolute need to use technology to support learning and teaching worldwide from elementary school to university it's reduced the resistance to the use of technology for teaching, and it has then led to innovation on both the teachers and the learners' part in making changes that can support both the individual and groups of learners. Furthermore, it's increased the outreach between the teaching and the research community to help provide resources that can facilitate teaching remotely and to analyze learning in the context of new learning situations. So one example is that virtual immersive environments have been created by researchers to provide tools that can facilitate groups of students as they try to solve a problem collectively. As one example, you can imagine a student represented in an immersive virtual environment trying to learn biology together. For instance, grade 8 students come to a virtual island and are met by scientists who say that there's an epidemic and can you help solve this problem? Why are islanders getting sick? So now students are working virtually together to solve this problem, formulating hypotheses, collecting evidence on the island, conducting experiments, formulating hypotheses, and basically coming up with a collaborative argument in a new way that they never have done before. So these things are happening, and by sharing viewpoints, they can reach consensus. And we can analyze this data with AI by looking at the log file interactions, the types of arguments they create, the textual, verbal communications that they have, etc. The other thing that I think is an interesting thing for research is the virtual immersive environments can facilitate research globally.
Okay, thank you so much. That's fascinating. Now we will move on to Professor Pai's time capsule video.
Hello, I'm Professor Nikki Pai. I'm an associate professor in the Department of Medicine, Division of Clinical Epidemiology and Infectious Diseases at McGill. I'm also a research scientist at the MUHC Research Institute. I'm going to talk about the biggest transformation that I will see in my field in the next 25 years. So in the next 25 years, the practice and delivery of medicine is going to undergo a massive transformation of sorts, a 360-degree change of sorts. Digital medicine will be powered by machine learning and deep learning, and it will be omnipresent. Patients will see doctors, patients will bring data to the doctors, data will become cheap, and research will change in tandem with all these changes. In my field of diagnostics in HIV and STIs, I do pray that I will live to see the end of the HIV epidemic within the next 25 years. And I also see that for other STIs, there will be a plethora of tests and platforms and technologies that will help bring about a change in the management, access to care, and will bring about a reduction in the transmission of these infections in communities. Diagnostics is the fabric and the foundation of the art of medicine. Big data, machine learning, companion diagnostics, Internet of Things, and platforms, digital platforms that seamlessly connect patients from access to engagement to retention in care will be deployed in programs nationally and internationally. My social impact wish is that all of these changes will not only bring efficiency and accountability, but will also expand access to care. And I do pray that this expanded access reaches the vulnerable populations that we deeply care about. Healthcare, digital medicine will then become the great equalizer in medicine. It reaches all populations regardless of their skin color or their ethnicities or their backgrounds or their pockets. I just pray that I live long enough to witness this powerful transformation in the history of medicine.
Professor Pai, your research focuses on infectious diseases, global public health, and social impact. In your video, you stated that digital medicine will become omnipresent and could even become the great equalizer in medicine. Since you made this prediction, the pandemic has brought inequities in healthcare into the spotlight. How has this impacted your research?
So throughout history, be it the Spanish flu, the bubonic plague, HIV, we've seen that pandemics have exposed the fault lines of society. And COVID-19 was no different. As we saw in Canada, we have neglected our seniors for a long time and they were impacted in the first wave. Commercial, non-residential homes that were doing a bad job of taking care of them were exposed. Across North America, the pandemic took a heavy toll on the lives of marginalized populations. So social inequity and inequity in access to diagnostics, to resources predicted who is going to be alive and who's going to not survive the pandemic. Now on to research. As for research, I think COVIDization of research is a term that we use because almost every research, I mean, we were desperate in 2020 for adequate drugs, for the right medications, for the right devices and vaccines. So a lot of money was released for COVID and 500,000 research papers were published in a year alone. We have enough and more knowledge to save lives. What is lacking now is implementation of those findings to really save lives. Although in the high income settings, implementation of research findings and saving lives happened in tandem. In other settings, they were the reason why it didn't happen was because there was a lag in understanding, guidelines were not updated, people were not sure what to do, and the system was totally overwhelmed. So systemic issues led to loss of lives than, lack of knowledge, which was really sad. We could have saved millions of lives that were decimated thanks to this pandemic. In my clinical research program, I think research recruitment really stalled. Nobody could recruit, and most of the fields like HIV, HCV, HPV, human papillomavirus, hepatitis C, HIV, we've fallen short of our targets, of our elimination targets. So we will need another 5 years to meet up those targets of elimination that we set pre-pandemic. Because we could not meet, I think digital medicine then and digital platforms became omnipresent. There was a reticence towards adoption of these platforms pre-pandemic, but because there was no way we could have communicated or done anything. So digital medicine has kind of come of age, if I can say that. And 2020 has been the year of the Great Awakening, the year of the Great Disruption, or the year of the Great Realization.
Thank you so much. That's so interesting and important research. I'm going to move on now to Professor Barrett. Okay, let's now view Professor Barrett's time capsule video.
My name is Rowan Barrett, and I'm an associate professor and Canada Research Chair at the Redpath Museum, and I work in the field of evolutionary biology. And specifically, I'm interested in understanding how organisms adapt to their environments. In the next 25 years, I think the biggest change in my field will be a shift in time and resources devoted towards understanding how climate change is impacting the evolutionary trajectories of the world's species. It's really crucial that we understand how and why some species can or cannot adapt to these drastic environmental changes. And I think one important discovery that will help us in confronting this challenge is the development of new environmental DNA, or eDNA, methods. So when an organism interacts with its environment, it's shedding DNA. And this DNA can be collected from environmental samples such as soil, air, or water without needing to directly sample from the organism itself. This makes it possible to rapidly survey large numbers of species, even very elusive or rare species, without needing to directly observe them. These methods can also make it possible to track the movement of specific genes through the ecosystem, which may be very useful for monitoring transgenes from genetically modified organisms. And I predict that in the next 25 years, advances in DNA sequencing technology will allow us to use these samples to identify, track, and quantify biodiversity with a resolution that provides unprecedented clarity into where species are found and why they're there. And this should hold tremendous potential for understanding how organisms adapt to climate change.
Professor Barrett, your research examines ecological and evolutionary processes and adaptation to changing environments. In your video, you stated that the biggest change in your field will be around resource allocation, specifically toward developing a better understanding of how species adapt to the drastic environmental impacts of climate change. Research has yet to determine the outcomes of the dramatic change in human behavior created by pandemic lockdowns. What learnings from your research are applied to the current interrelated global crises posed by both the pandemic and climate change?
Well, I believe that the climate change crisis will continue to pose an ever-increasing threat to human societies and to biodiversity, and represents the single largest challenge that we face and where we should direct significant resources. And part of the reason for this is the way that it interacts with and amplifies so many other important problems. And one of these is the risk of future pandemics. So we currently talk about COVID-19 as the pandemic, but it could be just the first of many that we face in coming years. So we know that climate change is causing habitat loss for many species and forcing them into areas with increased contact with humans. And these human-wildlife interfaces are places of huge risk for the emergence of zoonotic pathogens. So it's estimated that there are about 1.7 million viruses that we haven't yet discovered, with a significant proportion of these expected to have the potential for human infection. So we're always just one spillover event away from the next pandemic. And this is one area where the sorts of genomic methods that I mentioned in my video could be very helpful. So in the same way that we can use sequencing of the environmental DNA in a sample of lake water to identify, for instance, what species of fish might be present, we can use these same methods to identify the known viruses present in a particular animal host, as well as to discover new species. So these approaches are known as metagenomics because they're not targeted towards finding a particular sequence of DNA that matches a known species in the sample, but rather they take an unbiased approach to construct so-called metagenomes, which can be used to detect completely novel viruses and identify the evolution of functionally important variants. And partly due to the COVID pandemic, we've seen the rapid development of cutting-edge bioinformatics methods to handle this kind of data. So it's been really great to see how quickly progress has been made on this front, and also how this work has been communicated to the public so that many people now have, I think, a better understanding of the relevance of evolutionary biology and how quickly evolution can occur. So for a long time, we thought that evolution could only occur very gradually over long time scales, and that we could only study it using things like the fossil record. But I think that COVID and the frequent rise of new variants like Delta is helping many people to understand that evolution can sometimes also be a very rapid process that can have direct bearing on their lives.
Thank you. That's fascinating. All right, crisis can be a strong driver of creativity and innovation. Where have you seen innovation emerge in your research field in the wake of the pandemic? Professor Pai, let's begin with your thoughts on the subject.
Thank you. So we know that necessity is the mother of invention, and necessity drove creativity, innovation, and crisis became a driver in the COVID pandemic. As we saw digital health and connected diagnostics, these platforms were taken up so rapidly. They were even deployed in Africa, and never before had I imagined that they would be deployed at such a rapid pace. So that's one. Two, I think telemedicine, the uptake of telemedicine increased from 1% to 70%. And we soon realized that every doctor visit does not have to be at the hospital. Many of these visits, routine visits, could be, held over video or over phones. And so that leads to time and cost savings. And that realization would not have happened had pandemic not happened. And I think that innovations in drugs and vaccines, these technologies and platforms, mRNA vaccines were there, but they were lying on the shelf. When China released its genetic code, the mRNA vaccines were developed at a record time. EUA authorizations were, obtained from the FDA and from WHO in a record time. And these takes years. So I think we have now an example in front of us. And I think we could actually not get back to the old normal, but actually embrace the new normal and fast track innovation and deployment of technologies to improve the lives of people.
Professor Barrett, what about you?
I would echo many of the things that Nikita just said. But in terms of sort of my specific field of research, my research area involves sort of equal components of muddy boots field ecology and lab-based molecular work and bioinformatics. So the inability to travel to our field sites and study the organisms that we work with in their natural environments has, of course, been really difficult. And this has held back our progress in many important ways. But as I mentioned previously, the pandemic has also led to intense efforts to strengthen and accelerate computational and bioinformatic methods. So while I think everyone in my field of research is pretty tired of having so much screen time and would much rather be working with their study organisms out in nature, all of this time in front of the computer has led to really rapid progress and innovation in a lot of our bioinformatics approaches.
Very interesting. Thank you. Professor Lajoie, what about you?
I would just echo the fact that a lot of our research has to be distributed, and it's okay, to be working at a distance, and you don't have to be in the same time zone. You can still be collecting data virtually, through log files or any other systematic way of doing things. And I think that it's just facilitated our way of thinking about teaching, use and research about teaching and learning by having other activities that people can use. So maximizing the multiple representations that are out there with technology can really enhance a learning situation. One of the things that we also think about are learner dashboards and pedagogical dashboards. So if you're learning at a distance with, 8 different groups of people working on common problems, we can create pedagogical dashboards that represent each group's progress and each individual in the group, who's talking to whom, who's predominant. Are there dominant people, less dominant people? Are they listening? Are they all active? Are each of the individuals in the group making progress? By populating a dashboard with this kind of data, the instructor can make really quick decisions that will facilitate the group's progress. And so again, learning analytics and pedagogical dashboards and visualizations of the learning process using technology is an innovation that helps both the learner and the teacher.
Well, thank you very much for that. Okay, we have a third question here. So rapid innovations such as the development and distribution of mRNA vaccines in response to the pandemic has led many to believe that research can be deployed at lightning speed. As researchers, we know that innovations are often a result of research conducted many years prior. Is it too bold to say that the future you imagined has arrived? And if so, in what way? If not, what will it take now to get there? Professor Barrett.
Yeah, well, I think it's really important to realize that many of these innovations that appear to have been created quickly are actually the product of many years of hard work. So it's a bit like the band that blows up when they get a hit song. It seems to most people like they came out of nowhere, but they've often spent years practicing their craft in their basement before they make it big. So mRNA vaccines weren't suddenly developed when COVID-19 appeared, and the science behind them certainly wasn't rushed. So the vaccines we have now are building on decades of research, both fundamental and applied, on how to make synthetic mRNA, how to use lipid nanoparticles to deliver medicine into cells, how coronavirus spike proteins work, many other areas. So I think that this really highlights the importance of long-term investment in basic research so that we're prepared with a knowledge base that we can apply to problems quickly rather than being reactive and having to start from scratch to solve problems when they arise.
I could not agree more. Thank you, Professor Barrett. Professor Lajoie.
Yes, I simply agree. We've been working on technologies for technology-rich learning environments and AI techniques for many years. It's only it's not that we've just now into the classrooms, but now I think there's less resistance. And, basically people are realizing that technology is not going to replace teaching. It's going to be an asset that can, help both the learner and the teacher rather than, replacing the teacher. And, I think that was the same that Nikita had talked about with doctors being, more willing to meet at a distance, that there are some advantages. There are disadvantages too. I mean, you don't have the physical contact. So, and you don't see the social emotional aspects for teaching and learning. And I think that's one thing that we still have to be aware of, that we have to somehow be able to support the emotional aspects of learning and be able to recognize those. And that's still a place that needs work in this distributed learning and research and teaching environment.
Thank you. Professor Pai.
I agree with all my panelists who've given multiple different perspectives in their fields. And I think that digital medicine, in my space, I said in the video that it will take a couple of years, but I think it is the how and now and why. Now it has arrived. And so it's now we have to figure out how you're going to implement it in the best possible way. And how do you make this digitization of medicine the great equalizer? How do you take care of the inequities? There is a digital divide that exists. There are people who don't have access to smartphones or internet. There are about 40% people worldwide that don't have access to any technology. So we need to call upon corporate-private partnerships who are sending people to Mars, but use all of those dollars to actually make sure that everybody has access to education, because they will have access to internet and devices. We cannot leave the bottom billion behind.
Thank you so much. All right, thank you all so much. That brings us to the end of this special virtual event. I invite you to watch the time capsules, which are online at the URL on your screen. But don't wait too long. This spring, as the Bicentennial draws to a close, the videos will be sealed and then slowly revealed over the next 10 years. Thank you for tuning into this special event. Have a good evening.